Hello everyone, welcome to another electronics lab class. Today we will be doing lab number 5, which is the DC series circuits, and lab number 6 from the DC lab manual. We will start with lab number 5. For lab number 5 we need the following resistors. We need a 1 kilo ohm resistor, a 2.2 kilo ohm resistor, a 3.3 kilo ohm resistor, and 6.8 kilo ohm resistor. If you don't have those resistors, you can pick the closest resistor that you have. For the first part, we want to put these resistors in series and connect them to a power supply. For your power supply, again, you can use batteries, putting them in series to create a 9-12 volt battery, or you can use a power supply. I would also put a link for power supplies. They're around $40 to $50. I recommend if you're an electrical student, you will need that for your other labs as well. So it's going to be a useful equipment. So now to connect the resistors and measure the current and the voltage, the first step, I would set my power supply, which is here. I'm going to set my power supply to 10 volts for this one, but you have to follow the instructions. The instructions has mentioned for the first step you have to put it on 10 volts, and you need to use 1K, 2.2K, and 3.3K. So I would put the resistors in series. By the way, when you want to use the power supply, please first set the power supply voltage, turn it off, assemble your circuit, connect it, and then turn it on. If you turn it on and connect it, it may damage your circuit. So I can put the resistors like this in series. I'm going to zoom in so you can see better. One way to put them in series is I can simply put them like this. I have to connect the pins so they would be in the same, can you see it's same column? I would put it like this. Now these two resistors are in series with each other. And I would put the third resistor in series as well. So as you can see now, these resistors are in series. Again, these two pins should be connected to each other. According to our diagram now, I can use jumper wires to connect the first resistor to the positive terminal, and the last one to the negative rail. You can see here we have the negative and the positive rail, and by the way, all of these again are connected to each other. After setting up our power supply, now I can simply connect the power supply, the negative power to the negative end, and the positive power supply using another jumper wire to the positive side. Or I can simply, another way is I can simply directly connect it like this as well. So one way is like this, but when your circuit gets more complicated, it's better to use a common like rail and get the power from that common rail. But if I didn't want to use this rail, I could simply take this out and directly connect this wire to this wire. So now point A would be this point, my point B would be this point, the point C would be end of the second resistor, and point D would be the ground. So I want to measure now, I want to measure the voltage. To measure the voltage, I would need a digital multimeter again. I'm going to put the voltage here on 20. The terminals, the black one is connected to the COM, and the red one is connected to the volt, ohms, and milliamp. So I put it this way. I would put it on 20. Then I would measure the voltage. For measuring the voltage of the first resistor, we would put it in parallel, the multimeter in parallel with the first resistor. So we'll connect it like this, and we can measure the voltage of the first resistor. So, example here, if I measure the voltage again and see if I have the correct voltage. So measuring the voltage, the entire voltage here. It seems that my multimeter doesn't work. This one has a low battery. Let me switch to another multimeter. See if this one actually works. Yes. So usually when the multimeter battery is low, you would see like some odd numbers. It won't show you the correct numbers. I'm going to use again another multimeter. I would set it to the 20 volt DC, and again the terminal is one, the black one is connected to the COM, and the red one is connected to the volt ohm milliamps. First I can measure the entire voltage from positive to negative. It's going to be 10 volts, which was my source voltage. Then I can measure the voltage of the first resistor by putting it on the pins of the first resistor. Since it's lower than 20 volts, it won't show anything. I'm going to put it on 2000 millivolts. Now this shows that this 9 volt is actually the first voltage. Then I can measure the second voltage, which is greater than that. So again, this one doesn't have enough battery, but you can measure all the voltages by putting them one by one in parallel with them, and measuring all the voltages of each of the resistors. To calculate the current, so the voltage part is the easy part. To measure the current, if your multimeter is the same that you ordered from the website, the Amazon website that I mentioned, you're going to have something like this: the common port, the volt milliamp, and the amp. For measuring anything less than 1 amp, you have to put it in the middle terminal, and anything above 1 amp, if you want to measure, you have to put it on the terminal that it's on the left, connected to that terminal. So for measuring the current, you would put it on DC current, or around for the 20 milliamp would be okay. If it can measure it, we would change that scale. You would disconnect the first pin or the positive, and you would put it in another spot. Then you would put the ammeter in series with the system. So for example, here the current is around 9 milliamp. In series resistors, they share the same current, but the voltage is added up. So the total voltage would be the summation of V1, V2 plus V3. So V1 plus V2 plus V3 would give us the total voltage, but the current is shared. So if I move this to the next spot, and the first step I measured the current in point A, now I want to measure the current in point B. So I would disconnect these two and put the current meter in series, and you would see that we would have the same current. You would have a different value probably because you have different resistors. I just picked these resistors randomly, but if I change the spot that I'm getting the current, so I'm now moving from point B to point C, I disconnect this, I will connect these two together each other. As you can see here, these two are now connected, and then I'll put this in series with my system, and again you would have 9 milliamp. Again, connecting these two and getting the current from point C, you would still get 9 milliamps. So you will record these, and it's exactly the same for figure 5.2 as well. And then you would complete the tables. The only difference between figure 1 and figure 2, instead of 3 resistors, you would have 4 resistors. So you would add the 4th resistor again. You would put it on voltage. You would measure each voltage separately. And then you would disconnect them so you can measure each voltage and the total voltage. And then you would disconnect it. So for example, if I want to measure the current going into the circuit, I would disconnect it from here. I'll put this on current, and then I would put the current meter in series with the system. So it's going to be something like, it's going to be connected like this, and make sure that they make a connection when it's connected. So this is going to be the current that we're going to have. It's probably more than a few microamps. So check. So you have 9 milliamps again for this one. So this is the way that we would measure the current. For each point when you want to measure the current, you simply disconnect it. That point, for example, if I want to measure it at point B, I would disconnect these 2 resistors, and then I will put my multimeter in series between these 2 resistors. So if I want to measure again point B current, I would disconnect the first and the second resistor. All of them are still connected, and I will put my current meter in series between them. And I will complete the tables and answer the questions. For lab number 6, we have to put them in parallel. So to put them in parallel, if I have, for example, 2 resistors, I can simply put them like this in parallel. So I would put one over here, and so for example, to make it even more, I can put one in 1025 and the other one in 35, the input 25, the output 35, and I will do it for the next resistor. So this is how we do it for the parallel connection. One pin, the inputs of the resistors are connected to 25, therefore pin 25, therefore these 2 are now connected to each other, which is going to be point B and C. And on the other side, the outputs or the second terminal are connected to 35. These 2 are now connected to each other, which is the ground of our system. If we connect them like this, then they are not connected to each other. So these 2 are not connected at all, because these 2 are not connected, and again these pins are not connected as well. So the way to do it for parallel, we will put them like this again. So these 2 pins are connected and these 2 are connected, and then we can connect the positive and the negative like this. Now they are connected. Let's move this so you can see it more obviously. You can put positive and negative like this. Now these two are connected and the inputs are connected and the outputs are connected. To measure the voltage, because they are in parallel, they share the same voltage. So again, I'll put it on the voltmeter and I would put it like this, positive and the negative. I would connect them like this and I can measure the voltage, which is 10 volts. The voltage is again shared, so it doesn't matter which resistor I put it on, it's gonna always show me 10 volts. Now if I want to measure the current, this is the tricky part. For example, if I want to measure the current of R1 or point B or the total current. To measure the total current first, I would disconnect the positive end, I would put it in another pin, and then now these are completely disconnected. I would put my multimeter again in current and I would connect one end to the positive and the other end to one of the resistors. Now I can measure the current, which is in this case 1 amp. So again, I would disconnect the positive completely from the resistors, and then I would bridge my multimeter in between and I would measure the current. If I want to measure the current for one of the resistors, so for example, if the lower one, this one is R1 and this one is R2, and I want to measure the current for R1, what I would do is I would simply connect the positive end to R2, disconnect R1 and put R1 in another slot which is not connected to R1 anymore. So I would connect it like this. Now you can see that the positive and R1, these are connected, but they are disconnected from, the positive and R2 are connected, and you don't have to touch the negative. You have to keep the negative connected to the other terminal at all time. So I would connect the positive power supply or the positive side of the battery to the R2. I would put R1 in a different slot. Now these are disconnected, and then I would bridge the positive or R2, other side of R2 with R1, and I can measure the current, which here is like 90 milliamps, 900 milliamps, something like that. If I want to measure the current for R2, I would connect this to R1, and now R2 is disconnected, so I would connect positive to R1, and then I would bridge between these two, and the previous one was 9 milliamps, this one is 996 milliamps, and if you add 9 milliamps to 990, it should be around 1 amp, which you would see in your experiment as well. So the key is that you would disconnect one resistor at each time and measure the current of that resistor. For 6 part 2 is exactly the same, but instead of 2 resistors, now we would have 4 resistors. One way to connect them, you can just put them in one slot, or you can put them over here and then connect these two with a jumper wire, but I would do it, I prefer the easy way, so I'm just gonna put all the 4 resistors and between pin number 35 and 25, for example, and now they are all in parallel. I would connect the positive to the positive and the negative to the negative end. Now to measure the voltage, I'll put it on volts. And again, because they are in parallel, they all share the same voltage, which is should be around 10 volts. So if I measure all the voltages, they would all be the same because they all share the same voltage. Now to measure their current, so you can see that putting them in parallel, you put all the pins in 55 and 20, I'm sorry, 35 and 25, between 25 and 35, and you would see that all of them are now in parallel. Now the next part is to find the current between them. You simply disconnect the positive, and you will put this on amp, and you would bridge between these two and find, so you can find the current. I want to make a little bit of distance between these two so I can make a connection. Yes. And now you can measure the current. If it shows you this L, it means your current is too low and you need, this range is too low and you need to increase it. So now it's showing me 10.4, for example, amps. And now if I want to measure the current of each resistor, again, if I want to measure the current of these two resistors, I would just put them in another slot or another terminal. I would connect these two to the first two. I would disconnect the other two, and I would make a bridge between them. Now I can measure the current between C and D, for example. If I want to measure the current between B and C, I would disconnect the first resistor, or R1, and I would put R2, R3, and R4 in parallel. I would connect the power supply to R1, and now if I bridge these two between R1 and R2, R3, R4, I can measure the current between point B and C. So here I can measure point B and C. So for example, I think the current is more than this, so I'm just gonna go, yeah, it's like 74. So if you want to measure the current, you just simply disconnect the resistors and then you bridge that gap or that open circuit just using the ammeter. You would do this for figure 6.2 for between A